So as I was saying, I know it's short notice, but I did work on cleaning up some of the code in the Makefile, like I said yesterday. I also coded a timer and added a timer, which I think is the last piece that we were missing. And I did. What did I do? I also actually changed the SPI controller. I basically created my own, so I'm just gonna quickly show the RTL that I wrote this evening. That's this thing, platform.v. So it's a very simple RTL peripheral, which basically implements the timer. So in the last stream, I showed that the in the RISC-V, in the VEX RISC-V, I already had a cycle timer that was 64 bits. That was kind of wrong. I mean, the code does have it, but since it's not read anywhere, it was being optimized out, which means that it wasn't actually present in the hardware. So what I ended up doing is just doing a timer here, which is mtime, which is only 32 bits, which means that it wraps every 240 seconds. But since we're gonna be executing the timer interrupt like 100 times or 250 times per second, the wraparound is not a problem. We can detect it in software and handle it, and basically software extend the 32-bit hardware timer into 64 bits. And then I have a compare value, which is used to generate the interrupt. That's the standard way that it's normally done in RISC, the standardized RISC timer, except here it's 32 bits and not 64. That also means I need to handle the wraparound, because the compare value could be inferior but still in the past. And so basically I defined like half the 32-bit is the future and half the 32-bit space is the past. That's sort of what I'm doing here. Some other optimization I've done is that I'm actually only comparing 24 bits and not 32, because yeah, I mean it's a good enough resolution for us. And the other kind of small, but I mean, it's really an implementation detail, but I thought it was interesting, is that I'm trying to save every LC I can, right? Because the FPGA is like very, very full. And so in theory, to do the comparison between the trigger time and the current time, I would just do one minus the other, okay? And so basically what I would write is something like, mtime diff is mtime minus mtime CMP, okay? Now, the way minus is implemented in a logic is that you do a plus of the number, the opposite of the number, and the opposite of the number is you invert all the bits and you do +1, okay? And so you end up with this, essentially. And the +1 is implemented by the carry feed-in of the other chain. But the thing is, in the iCE40, the negation here, because of the way the carry logic exists in the iCE40, the negation here can't be packed in the same lots, which means that to subtract two 24-bit number, you need 24 LC to do the inversion and 24 LC to do the actual addition with the carry chain. And here to win some LC, because this value is essentially a register, I can directly store in the register the inverted value here and basically get rid of 24 LCs that way. That's sort of why it's written that way. This is really a subtraction, except it's split in two parts, so that I'm basically winning some LC. What I'm hoping is that I didn't change the file, because else okay, I didn't save the file, because else I would have had to rebuild the SOC, because the timestamp would have been modified, so that would have been bad. And the other thing that that's in this file is a very small SPI controller, which is really just a counter that counts like 8 cycles and a shift register that just shifts 8-bit in and out. Because although the iCE40 up 5K has a hardware SPI core, it's actually first pretty slow, and secondly, implementing it myself doesn't actually take much more logic because this controller is very simple, and the kind of more complex part of the logic is the bus access, plugging it to the wishbone. But since I need to plug in the timer anyway, I've kind of merged both logic into one so that I don't waste too many LCs. That helps save time at load. So the other thing I did is rewrite basically completely the boot thing, the loader, because else, if you remember last stream, I basically had a bunch of hard-coded SPI read value. Now it's actually a little bit nicer where you have a manifest where every time you have what you load and from where. And so what I'm gonna do now, so this is so the first thing I'm gonna do is actually iCEBreaker. I'm just gonna erase the entire flash to make sure that I don't have any weird stuff in it. I can start this. Oh wait, I'll probably have it open in another. Yeah. Add it in another console. I have a small demo app. So you remember the first mem test application that I wrote to test the HyperRAM? I've kind of extended it to test my platform thing, to test the timer. And so it has a very simple interrupt that basically triggers every second. That just proves the concept of the interrupt working. So I'm gonna flash the firmware app actually. This may okay, so this flashed it at offset 640K, and if you look in the boot code, you can see that here I've just told him to basically load from address 640K, load it into HyperRAM, load 16K, and then when the length is 0, so every time, okay, it's not very clear here, but this is the destination address in RAM, the length to load, and the address in flash. And if the length is 0, it's a kind of a special token that instead of loading to SPI, it will jump to that address. So basically what I'm telling it here is to load 16K from flash at address 640K, load them in HyperRAM, and then jump to it. So I've just loaded my demo application at offset 640K. Now I need to actually load the bitstream because I've erased the flash, so the FPGA isn't even configured at the moment. Okay, and now it's is there a way to pause the output? You can see it basically triggering every second. You can see the time incrementing. That's the time counter, the 32-bit time counter, and it's generating MCO7, which is timer interrupt trap every second. So our hardware timer works. Now we just need to plug it into the Linux kernel. So let me comment this out because this is just for test. right? No, I've just erased the flash, so I need to reflash everything inside the memory. And I will do that. I will start doing that because writing takes some time, right? Hey, yeah, hi. Yeah, I was actually coding, like debugging my SPI controller while watching your stream. So yeah, I wanted to start flashing this because it's gonna take forever. So what was I gonna say? So I'm gonna place this actually at offset 9. Wait, no, I'm gonna press offset 9. I mean, it doesn't matter in which order you load them. It's just for me basically. And I'm gonna load this at offset. What is 9 by 128? 9 by 7 by 128. 896K. So at offset 896K, I'm gonna load 2K of the DTB. Okay. So I'm gonna flash these different things at the right offset in RAM. The right offset 896K, and so I need to flash the DTB, which is in DTB rv32.dtb. So that's rather quick. I mean, it's still rebooting my demo firmware, but it doesn't matter. I'm gonna load the root FS, which is at offset 9 meg. And I find this in here. Actually, I probably need to. No, it's okay. It's already compressed. I have it here. And then I will need to flash the kernel at. Okay. I'm just gonna wait for that to complete. Then I will launch the flash of the kernel. And while it's actually flashing the kernel, we're gonna look at adding the support for the timer into the BIOS. So everybody clear on the state where we are and the few next steps that we need to take before we can actually try booting it? Hopefully that shouldn't take long. I mean, it's really just a few register access. So, okay, and then we can flash the kernel image, and that is at offset 1 meg. Okay, and while it's flashing, we're just gonna have a look at the BIOS. Okay, so I think I've already copied the config, the new config.h. Yeah, so I have the platform-based thing here. Okay. And so the function that we need to implement are basically those 3 functions. Oh yeah, if you're wondering why the LED wasn't working yesterday, it was actually working. No, it's not. It's actually a full MMU enabled Linux. It's not. It's just the plain standard RISC-V v32 Linux with MMU and everything. Which is kind of the challenge, right? Because the up 5K is really really small. Yeah, it's a Vex RISC-V, which is known to boot Linux. Like people have booted Linux on it, like on the ECP5 with no problem. Here, if you haven't followed the previous stream, is basically we're trying to boot it on the iCEBreaker with an HyperRAM PMOD. And so I have a 32 megabyte of HyperRAM attached to the up 5K, and I'm trying to fit Linux enabled with MMU and HyperRAM controller, L2 cache, L1 cache, all of that in about 5,000 LCs basically. So yeah, yesterday, just before quitting, I tried the LED thing. It was actually working. It's just that I had the blinking rate configured a little too slow, and because it was configured for a higher frequency, because I usually run the cores much faster than we're running it here. Here we're only running it at 15 megahertz, but because with the MMU, we can't really go faster on a 5K. Here I'm just gonna set up the LEDs, and then we need to, so as I said, the three functions that we need to implement are these three here. One returns the MSB of the 64 bits time counter, which we don't have. So we're gonna basically have to make them up. This is the LSB of the time counter, and we just need to return them. And then we have CPU timer CMP, where it gives us basically a 64-bit value, except split in low and high parts. And we need to set up the interrupts so that the interrupts fire when that time has passed. And then the kernel will handle the rest. So I have the register definition for my little platform thing, which includes the timer. So the way we're gonna make up basically the LSB is that we're gonna have static ENT32 timer LSB. We're gonna basically remember what the last value of the LSB is, and if we read a LSB value which is smaller than the previous LSB that we read before, well, we know that we have wrapped around, and so we need to increment the MSB basically. That's what's going on. UNT32 timer LSB new, and so we read them from the hardware timer, and if this is smaller than what we read last time, this was incremented, and then timer LSB equal this. And then we need to return timer LSB. Actually, because we need to do that every time. Thank you for the follow. Sumit. We need to do this both when we read the LSB and the MSB. So I'm just gonna make a single function basically. Timer LSB. The next thing is setting up the timer compare. And so we basically ignore the MSB, and we just do that rec timer. Oh yes, something that I haven't shown. Like I'm actually I'm actually using the LSB as a special indicator, basically. And so I need to clear that indicator. It's just to detect is the interrupt enabled or not. I think we're good. Okay. Oh. Fuck. Damn it, something failed in programming the flash. Kind of the first time that happens to me. Never seen that before. So yeah, we need to reflash the kernel. Yeah, unfortunately, I actually did look in the source code of iCEBreaker if there was some way of speeding up, but it's already running at the maximum clock of the FTDI, so nothing we can do about that. Yes, I'm hoping I'm actually done. Like in theory, I just need to because I've just changed firmware boot and the BIOS, so I just need to update those and program them, and then it should be working. Fingers crossed. At the moment, I'm just hoping that the programming will work. And then there is some minor room for optimization because I've actually disabled an option of the VEX, the data path bypass. So it's when when the result of one instruction is used by the next one, in theory there is in the pipeline some special path to bypass the register file so that you can execute those instructions directly one after the other without stalling the pipeline. I disabled that to win some space. And unfortunately, that's kind of a big performance hit. That's like that's probably like a 20% performance hit, just that thing. So that's something I would really like to be able to re-enable, but if we look at the there is some, I mean, there is some free space. There's exactly 300 LCs of free. So I don't know if that will be enough to re-enable the data path bypass. Because what happened is that when I plugged the timer and the init, the timer itself is relatively small. I think it's the timer plus the new SPI controller is like 120 LCs or something, which should have fit. But the thing is, because before the interrupt signal was hardwired to 0, a bunch of the logic was getting optimized. And now it was connected to something, which means all that logic couldn't be optimized anymore. And so the size is raised more than just the size of the timer itself. And that went ever so slightly above this. But that was in a previous version of the code. This one might be. What does the interrupt or the data path bypass? I don't know. I think it was a few. I think it was like a couple of hundred of LCs. We will try to re-enable it afterwards. If that works. So okay. So now I just need to flash the new. I modified this so that it loads the kernel and stuff like that. So I just do make prog init. So you can see the loader now prints the chunks that it's loading, where to, from, and so this is actually loading the kernel right now. It used to take like 40 seconds with the previous SPI controller. Now it takes like 10 seconds. Hey, look, the time is valid. Okay, so unpacking the init from FS still takes forever. Oh, but here we switch to clock source, RISC-V clock source. Yeah, uncompressing 2 megabytes is apparently a big job. Well, it's not booted yet, but that's definitely pretty good. I mean, that's what so far that's what I expected to do, right? Okay, this is starting to be a little long for my taste. Huh. Oh, wait, no, never mind. So, yeah, it takes like a minute to decompress the initram FS. Okay, so far so good. I have no idea what the hell that is. Okay, and it seems okay. So it doesn't seem to start user space. We get stuck at run init as an init process. So, okay, I'm not sure how to debug that because we can't simulate 87 seconds. That would be Oh wait, no fuck. Oh no, it's just slow. That is user space. The fuck? Oh yeah, it says unpacking failed because the size of the init RAM FS that I give is too long, and so it tries to decompress. You can have several init RAM FS one after the other, and so it reads the beginning and then tries the next one, but the next one there is none after, and so it fails because the next one isn't valid. Yeah. Starting network. Yeah. I mean, obviously, I mean, this kernel and this user space image have a ton of things that don't make sense. Like there is no network to start. We have a prompt. Can somebody clip that? That is fucking ridiculous. So there you go. Can you boot Linux on an iCE40? Yes, yes, you can. That's why they pay me the big bucks. Yeah, I wish. Total. So I mean, I probably worked like an hour between each stream. So the two first were 5, and the other one was like a 2 hour and a half. So that's like 12.5, 14. It's like 15 hours. 15 hours of work, probably. Yeah. I mean, obviously, like I'm standing on pretty big shoulders, right? Because not only did I have a bunch of the stuff coded, like I had a HyperRAM controller already written. I had the cache controller already written, the Vex burst interface, and all of that stuff was already written. But all of this depends on the Vex, which is like super configurable, and so it's like huge work by the Vex team, and Dolu on Gitter for guiding me and answering my question, to the Linux on Lytix, and so I think the main developer is like Florent at Enjoy Digital, right? I'm reusing tons of that work, and GateCat, of course, which also has been between the streams I was asking questions to try to understand what was going on, and they answered basically my question, and guided me, especially through the fact that recent Lytix Linux on Lytix trees are designed for SMP only, and so I had to go back to older tree to find what I was looking for, basically. So yeah, that works. That is very cool. I mean, obviously it's slow, right? It took like 87 seconds to boot. How does that compare to the first Academy batch port? I don't remember how long it was taking to boot. Do you remember, Michael? Yeah, that I have no doubt. Something that I want to try though is because that's been kind of annoying me. I didn't want to change it because I knew that it like the thing was working. Like we were seeing some messages with that option, but in the configuration of the kernel, if I can find the window where I have that here. So if we look in the config, we have the hertz value, which is like the how often it gets to the interrupt, and it's 250 hertz, a little high for my taste, because that probably has a high overhead. Yeah, I know they optimized it. Yeah, I know. I figured they did as much. But here, most of the time, it's actually spent like 60 seconds or 62 seconds of it is decompressing the CPIO image, which is kind of crazy, but yeah. So I wanted to try to at least diminish that value. I just need to know, how do I edit the Linux configuration? The root. There's the linux.config here, which is... Okay, so it's not specified here. So I could disable network. I think that'd be a good start. Okay, wait. I have a frame buffer configured. Like, why the fuck? Oh, that's definitely wrong. That should be no. Okay, so I didn't find the hertz value, so what I'm gonna do is just add it and say config hertz 100 equal yes. No. Config hertz equal 100. So I'm gonna try to rebuild this and hope that it picks up the new configuration. Oh wait, let me catch up on chat. HDMI PMOD, yeah, I don't think so. Like I have like no logic left whatsoever. The only thing I could possibly add is because I have the SPI controller, I could add another chip select and plug like a SPI screen or something. That would be doable, right? Because that has no logic. I need the logic anyway to access the flash. It's already there. It doesn't, like a chip select is gonna cost me like one register basically. Could you save some net by using the 8 DSP block or something? You know what? Maybe. Like the multiply would be useless, but I could potentially use just the adder part and make like a 32-bit adder out of it. That's actually... Actually, I could have implemented the timer using that. Because I could have implemented the comparison using the adder from the DSP. And that would save me like 100 LCs. With 100 LC, I can probably implement a video timing generator. I'm not using the two. There's currently we only have 64K of cache, which means that we have two SPRAMs that are free. That could be used as a 320 by 240 frame buffer. You know, yeah, there might be something there. I'm not gonna do that. No, I probably won't do it on stream because I want to experiment a little bit, mostly with the configuration of the thing. Wait, did it reconfigure at all? Yeah, I think it did. Okay, yeah, it loaded the new value. The nice thing is that the kernel is like 4 MB instead of 7 now, which is nice. Um, so let me actually modify this, and instead of loading 8 MB, I'm gonna load just 5 MB because we don't need to load the rest. I could do this. I just need to flash the new kernel. Yeah, I'm sure there's plenty of stuff that I could disable. Here I mostly wanted to disable stuff that takes time at runtime, right? The Hertz config, that was it, because it's triggering like twice as many interrupts. Um, yeah, probably, which obviously would speed up the boot, right? The CPIO was 4 MB, I think. I mean, technically there was space before for it as well. Like, I mean, it really wasn't that big. It just took a long time to load. Um, what I'm wondering is there a way to not have it decompress at all and just have like the but it doesn't even need to decompress the image, because at the moment it's just like decompressing it, but even if it's just CPIO, it's just extracting it into a RAM disk. Is there a way to just put the RAM image basically or something? You can check the size of the so it's 4 MB. And is it, so it's ever so no, it's actually smaller than 4 MB, so it would fit in 4 MB. So we can try that. I'm just gonna let it boot here just to see if it somehow feels faster at runtime because of less interrupts. At least it boots, so there's no problem with the new kernel configuration or stuff like that. It might have problem when it says like initializing network, because obviously that's not gonna work. I mean, look at that, already went twice as fast, right? 36 seconds instead of 65. Just lowering the hertz value and not wasting so much time in interrupt. Uh, yeah, okay, that's not surprising. I don't know if I'm limited by the speed of the console here, but so yeah, it works. Let's actually just flash this. We need to modify the DTB, and we need to modify this to the 4 megabytes. Where's the DTB? Okay, DTB. We can actually remove this because we don't have a light you out in the end. And where is the A, B, C? We need to reprogram the new DTB as well. Hey, hi, Ati. Oh, I can't type anything, of course. While it's booting, we have a, like you can see, we have a. Okay, I can't. I just did a gigantic ls, so the history, but you can see it booting and yeah, going to build root and shell and everything. We're just trying here instead of using a compressed rootfs, just feed it uncompressed because it like I think 75% of the boot time is decompressing the rootfs. So. Okay, so now we're loading 5 megabyte of kernel and we'll be loading 4 megabyte of 4 megabyte of rootfs. So yeah, looks like the okay, so it's much faster, but it still takes like a bit of time. But it's it's definitely much faster and compressed. A full size kernel image too? What do you mean? Well, I mean, Peter, so now we basically booted in like 24 seconds instead of 86. So it's better. Oh yeah, here it's not. The kernel is not it's not gzipped. So the two things I did is first change the config hertz value from 250 to 100 because I mean, given that it's a relatively slow system, there is no point in doing task switching 250 times per second. 100 is like way enough. And the second was actually switching to an uncompressed CPIO archive instead of a compressed one, so we don't have to decompress it. Does it? I mean, the init from FS is all in RAM. You don't have a choice. And anyway, we don't have access to Flash currently from Linux. But definitely everything that's in the image is not needed to boot, right? I'm pretty sure. Yeah, like I have VI in here. Like, what the fuck? I don't need it, right? I mean, it's remarkably responsive. Like for a text editor, that's like not a problem. Like you can edit text, no problem. It's not laggy or anything. It's fine. So yeah, that is pretty cool. So I wanted to try to compile to rebuild with the so change the vex configuration to re-enable the data path by path. Just do this. So at the moment, pretty sure that the vex that I've configured at the moment is exactly the one that's in here. Yeah. So I'm just gonna rebuild it with data path bypass. So at the moment we have 4980 LCs, basically. Let's try to rebuild with the data path bypass. Yeah, we need, I mean, we have support for the FAT file system. We have a SPI controller which can access the flash. That's not that slow. I mean, it's, don't get me wrong, it's slow, right? But it's not unusably slow, I would say. So I'm not sure I will work on it, but if anybody wants to try that, I will clean everything up and push everything. You need to synthesize the new bitstream on Linux, on iCE40, and Flash itself. Yeah. I'm not even sure anybody has done that on the CP5. Actually, I think somebody, maybe a Blinky, I don't know. Like, man, that would take forever. Especially this one. Like, this one is taking forever. Oh, apparently it fits because it continued running, like it didn't crash. It's doing routing. So how many LC are we at? 5197. So how long did it take to boot? So it took 24.2 seconds to boot. I want to see with bypass if that, how much of a performance difference the bypass makes, basically. If this ever finish routing. This will take a while. Yeah, it's taking forever already on my PC, so come on, you can do it. Sorry, just catching up on the. Yes, Bob. It is. It is booting. It is booted here. Look, we have VI running on the iCE40 on Linux. Really, I mean, the only thing it was missing was the timer. So that's what I implement. I actually implemented it off stream and I mean the hardware part, and I did the software support in the emulator here on stream at the beginning. That took like all of 10 minutes, and then it basically worked. Yeah, it goes through the space, and yeah, it is indeed a pretty. I mean, that didn't do anything. Oh wait. Yeah. Okay. So that works. That's fine. I have no idea what else is in that image though. Is there anything fun in the build root image by default, or is there anything that we can easily add that would be fun to run? If anybody has suggestions, something that I can just quickly add to build root that's already there, or where I can just change an option or something. There is Buzzy Box, but I have no idea what. Yeah, there's nothing fun in Buzzy Box. I don't know if there is anything. I doubt that there is Python. Yeah, no, there isn't. So I think there's probably only. There is wget, like super useful. We don't have a single network interface. We don't even have network support anymore. But we do have. I have no idea what microcom is. LSPCI, yeah, super useful. NetHack, I don't know what is NetHack, and is it in build root? Like if I can just rebuild an image with it and with a second UART fit, I doubt it. I doubt it. It might be possible to make like a multiplex UART instead of a second one. It's basically the same code and just can output on but that wouldn't solve the input. Because I mean the UART is like 100 LCs. I mean, technically I have them, but it's gonna take like the entire night. If I had 100 LCs to this, it's gonna take the entire night to build. Like it's already taking forever. It's progressing, but it's not. Yeah, right. Yeah. It should be in build root. Yeah. So yeah, if you want to encourage GateCat to release like a GPU accelerated version of place and route, that'd be nice. Because my place and route times have basically exploded. The I2C is not exposed to the core mostly because there is no I2. I didn't even like there is an I2C block, but it's not connected to anything currently. Um, the SPI is exposed to the core, and so adding a couple of chip select would definitely be possible. Um, Meaning you could plug an SPI screen and GPIO expander to get a keyboard if you wanted to. You looked and it's not available? Damn, too bad. I'm not even sure where you list the package supported by. Okay, I'd like to point out that this place and route has been running for literally 10 minutes. I'm not sure if it's ever gonna complete, honestly. I think that's gonna be the last rebuild test we're gonna do because I mean at 10 minutes a pop, that's kind of boring to wait for it. Um, oh, okay, yeah. I need to because something else that I wanted to check um, is how often is the memory accessed? And so I wanted to basically redirect the chip selects from the HyperRAM and put them on the LED. So you can just with the brightness of the LED, you can see how often the RAM is accessed. But that requires a rebuild, and I'm not gonna restart now. I also need to test with 128K of cache instead of 64 how much speed up that provides. That's something else that I will also rebuild, but I'll do that off stream because it's taking 10 minutes and it's not finished. It's probably gonna take another 5 minimum. So do I have my stuff for the build route published somewhere? My stuff for the build route? I mean, no. I'm not sure what you mean by my stuff for the build route because I basically the only thing I changed for the build route. If I'm getting lost in all those consoles. So that's what in the Lytix repo here. And so what I changed is the Linux config. That's to build the image. Yeah, I changed the banner because it's not Linux only on Lytix. So I updated the banner. And then the only other config that I did is this, but that's for the kernel because it's built 5.12. And then in the build root config is to put RVM to no so that it builds without the multiply extension. Yeah. I had faith that it was gonna work, so I figured that I need to change that before so that when it does work, it shows up properly, right? 1916. Come on, you can do it. What else do we have? We actually have okay, set key code. That's like super useful. I think some, yeah, I mean, like a driver for the Flash would be nice because then we could have a real file system, right? What are the numbers? What numbers? Oh, what they mean? That's the elapsed. So the only two that I know is that one, which is the elapsed time in seconds, and this is the remaining number of arcs of nets of arcs to root. So this goes down to 0, and this goes up to infinity currently. The other, I don't remember what they mean. And of course, yeah, it's I don't know how to pause the scrolling. Every time it outputs something, it scrolls to the bottom. So yes, as then that's what you want. And you can see the like if you look at the Linux at the GitHub page, there is the generating the Linux binaries. That's what I did. Basically, yes, it has about 1800 arcs to root. So that's what I did, and the only relevant change. I mean, I can. Let me see if I can just quickly push my changes to a clone. Okay, I need to do that on my laptop because I'm not logged onto GitHub on these machines. So it's what is the repo? LightXHub, Linux on LightX Vex Risk 5. Let me fork that. Linux on LightX, git remote at GitHub. I need to actually commit everything for that to work. Git push GitHub add to so now if you go to here and there's a branch with my changes. So where is it? Man, it's just not moving forward a whole lot, right? So probably sort of what happens when you get to that level of it is important. Do you have GPIO at all? No, I don't. This talk has nothing. Like I removed every single thing I could remove to fit. Like, like don't expect this to be all that useful, right? I mean, the thing is, I'm sure we can shave off a bunch of. I mean, okay, a bunch might be pushing it, but we can probably optimize the several things in the SoC to try to win lots at the various places. No, we do have hardware SPI. I mean, it's not. I'm not using the hardware block that's included in the UP5K. I'm including my own hardware SPI because it's actually faster than the one that's built in. It is. Well, I mean, it's available to Linux in the sense that you need to write a driver for it, but it's exposed to the soft core. So it's memory mapped somewhere, and yes, exactly. It's to access flash storage. No, we need to add another chip select, but the chip select would literally be like 1 or 2 LCs, which is we can probably afford that. Well, I mean, you feel free to. Like I don't. Let's take a look at the Lightx driver for SPI. If we can find it. Okay, that's not the source code for. So I can actually remove my debug print from there because it doesn't matter. So what are yeah blah blah blah. What I want to know is what function do I need to provide? Okay. Version 3 master package. Three, no. I'm not looking at the right place. Oh, oh yeah. Ah, okay, yeah, here. Okay. View PDF. That's just GNU radio. Yeah. That would be. Just gonna connect the Conrad, we can connect the SDR PMOD you made and not run GNU radio. ASCII invaders. Question. Okay, like I don't know. Build root at all. So how do you add a package? I know, really dumb question, right? But I haven't used build root in forever. Make menu config. Yeah, but what I'm wondering is if that. Okay, I mean I can try it, but the question is, does that interfere with the? I guess not. I guess it's only set up the. Sorry, it just started heavily raining outside. I was just making sure it wasn't raining inside. Yeah, that's what I'm wondering is, do I, because my thing about it, my impression was that the config file was sort of the initial config, right? Because you run def config, which means that afterwards I can still maybe modify it. Yeah, we definitely had issues with too much rains here. I mean, in Belgium. I mean, in where I am, it was fine. But I mean, I can try to type make menu config. Okay. I don't think Doom is gonna work. So does anyone know what ixocurs is? Okay, so it seems to be console based. So Try that. So the console UART is currently running at 1 megabaud. I could boost it to 2 if I wanted to. It's not much of an issue. Oh, it's slowly getting there. Oh, wait, it regressed. It went to 2282. I know it's at 1424. It's rising. Ah! Come on, it's almost there. Actually, can I remove some things? Good, because I was sure that I've seen some of these on the image, and here they don't seem to be. Okay. Linux. No. Output. Because now the image is of course larger than the image is no more like 5 megabytes, so I need to change that. Oh, come on! Yes! Okay, I'm just gonna save that build to make sure that if by mistake I do something that reprograms it. So I just want to see if that help perform, if the data path bypass helps performance at all. When booting, basically. Yeah, so it's a tiny bit faster, but it's not as much of a difference I thought it would make. From 24 seconds to 20.4 seconds, basically. So 4 seconds. I mean, I guess it's sort of significant, right? It's so like 15% or something, which is not bad. But you know, if I needed to sacrifice those 200 LCs to put some more peripheral logic or something, maybe that would be worth it. That's just. I need to try also when using more cache. But I won't do that here because I mean it took 30 minutes to do this build. I'm not gonna do that on stream. I will do several variation of different options and try to compare just the boot time as a rough benchmark and post results of what I found. Now I want to flash the newer image with the stuff added. So for that, I need to because the CPIO image is no larger than 4 megabytes, it's gonna be 5 megabytes. So I'm just gonna add this here so that we load 5 megabytes out of flash. We need to program the image here, and I need a new DTB. That is 5 megabytes as well. We need to flash the new DTB as well, of course, once this is done. The problem is, I mean, I have a serial console. I don't know if Minicom, what terminal type does Minicom emulate, and if it's configurable. I mean, obviously Vim seemed to work, right? So that it's obviously doing something, but flashing is slow. Damn it. I think it's emulated by Minicom. Oh yeah, it's not gonna work because the image is not complete. Wait, did it work? No. No, it must have crashed badly because the DTB is not. Unless it ignores the end. Yeah, it's missing some files because it basically dropped the 512K, the last 512K. Well, the project as well today is the day. We're, I mean, you're about to see the boot live. I mean, we've already booted it several times, but it's rebooting right now. It's okay. There it is. You can see compared to yesterday that the time is correct of the printf. Interesting that it booted faster this time. I have no idea why. Yeah, CPIO is just concatenated, but I would have expected. I mean, it would have been like a very lucky thing if a file ended exactly at the. The thing is, it's not smaller; it's bigger. It's like 5 MB. It's like 4.5 MB instead of 4, and it went faster. What the hell? Or maybe something didn't quite go right. Did I screw up something? Okay, whatever. We'll just see if we have the binary that we are interested in. Yeah, I'm gonna say that the entire build route didn't load. That's why it went faster. No, Michael, you're correct. I didn't, yeah, and Dimitri as well. I didn't update the, good catch. Yeah, good night, 26 Tech. See you tomorrow, I guess. I guess you will stream the, at some point, trying to debug the various cards or stuff like that. Because you got a bunch of cards with the Apple IIe that you unplugged for the test. Yes. Okay. By the way, then I don't know. You should probably add him to the streamer group so that you can ping stream watchers. On Discord, yeah. Oh, okay, perfect. Okay, so now it was slower, which is what I expect, and it's not complaining. So we can try the package that we added, which I already forgot. Okay, much more things. Yes, something isn't right. Yeah, something is definitely not right. I mean, okay. It's doing something, but not what you expect. Although something that I'm thinking, the screen size look, yeah, but what screen size am I supposed to use? Like, I only have, I mean, I can put it full screen, but I doubt that's gonna be better. As soon as I move, it's scrolling basically. Yeah, I can't remember. How do I kid it? Okay. There was Exo Curse, and there was a third one, right? I can't remember what it was, but I have no idea what I'm looking. Oh wow. I have no idea what that game is. Okay, fantastic. It works mostly, yeah. Something I was thinking now is currently the console we're using is through SBI, right? Which is convenient because it was easy to implement, but it's also super slow because every time we want to exchange one character, we're executing a software context switch from supervisor mode to machine mode, back to supervisor mode. That's a hell of an overhead to exchange one character, right? That's probably why the console looks much slower than when it should be for a 1 megabyte UART. And that's probably why LightX as an actual console driver, Light UART, for um, for the UART, they don't only rely on SBI. It's because yeah, speed basically. So implementing a proper UART driver would be a good idea. Implementing a SPI driver would be a good idea as well. You can enable color on Minicom. How do I do that? streaming games and yeah. Didn't I add like a Tetris clone here? I thought I did a Tetris clone. iTris? I thought I added it. Let me recheck. Oh no, oh no, wait, no, that was frauds. Okay, so apparently you can't run it as a root. Does it complain or something? I won't run as root. Oh, Jesus fucking Christ. Yeah, I don't care. Oh, but okay, you need story for you. It's an interpreter or something, and I'm guessing that yeah, you need data files, which I probably don't have, so I can't actually do anything with that. I'm guessing there is no provided. Yeah, no, there is not. Okay. Minicom-C. Okay, let's try that. Oh wow. Um, how was that game called? Is it better when you have colors? Well, I have colors now. Oh, that was the delay we were seeing. It's like the intro. Make the window bigger. I mean, it's did I just lose? Oh, wait, no, that was replay. I meant restart level. Absolutely, you have to go through the intro animation every time. Arrow keys, it's okay, yeah, it's a maze game. That I did get that far. Arrow keys, collect treasure and find the map pieces. I'm running on the iCEBreaker. It's running on this, basically. Ah, okay. Oh, fuck. I locked myself. Okay, I mean, anyway, I'm not gonna play. I'm not gonna play that, but that works. And as I said, I'm sure that if we coded a proper UART driver with buffering, it would probably, um, have a much improved console speed. Um, no, I don't want to keep Minicom. I want to keep the game. Control C. Okay. So you can have. Our VI doesn't have syntax coloring, right? Yeah. How much gateway does this take? All of it. I think we have like 100 LCs free or something. If we look at the report, yeah, we have 103. Wait, no, sorry, we have 83 LCs free. But something that's not nice is, if you look at the report, this took 1922 seconds to do the place and route. It's like 32 minutes. I mean, I built Bitstream for Kintex 7 faster. I need a faster computer. Well, feel free to send one my way. You have my address, right? Okay, I think I'm pretty much uh gonna stop here unless you guys have something quick that I need that you want me to try before I close up. Yeah, you expect things. I think I only buy new hardware for tier 3 subs. Okay. So nobody has anything to try? That doesn't take like 2 hours because the next thing I'd probably try is try different CPU configuration, but that takes like 30 minutes per configuration, so I'm not gonna do that on stream. I need to build like a script that build them in parallel so I can try them quickly. I'd want to try to write an SPI driver, and I'd want to write a console driver, but I will probably only do those once I've pushed everything so that this can be reproduced, basically. You want to see cat proc CPU info? Sure. Wait, is that the... Somewhat unimpressive. Message grab dash e bugger. I think it's still the hard-coded value. It doesn't. It just uses the rm-rf. Well, I need to be root for that. Is the Vex the smallest possible CPU that can do this, or are there architectural modification that would save a significant amount of LC? It is the smallest that I know of that I can build. It would be possible to make a small. I think it would be possible to make a smaller CPU that's Linux capable. But you'd have to tailor it, especially to the iCE40 basically. But I think it would be possible, yeah. Thank you, Esden, for all the gifted subs. Well, I mean, here it can't remove /proc and /stuff like that, but I'm pretty sure it erased the rest of the file system. And there we go. You can't do anything. There's nothing left. There you go. Could it be? Could serve be made to boot Linux? Yeah, I mean, you will have to add a bunch of stuff to it because at the moment it can't. Because it doesn't have an MMU, it doesn't have machine mode and supervisor mode, and it's missing some of the CSRs. But there is no reason you could not extend it to boot Linux, and it would probably end up smaller than the Vex. Yeah. But I actually like the idea from Conrad, I think, to use the DSPs to try to win some LCs back, because you can move some adders or registers purely in using the DSP blocks. That's actually something that I used previously. Like if you look, I, 'cause, 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 ' So the iCE1 USB, which is like the iCE40 based E1 interface thing, is very full. It's like in the same realm of 95% full. And inside of it, there is a bunch of fairly large timers. Yeah, which are used, and I've actually used the SB-Max16 to implement all of those timers just to win back some space, basically. So yeah, I'm using the SB-Max16 here purely as a bunch of adders and even just to hold values, because I can use some of the internal registers just to hold some values because they have clock enable and stuff like that I control. That's definitely an option. Yeah. Anyway, there, we've completely nuked it. So we can't do anything anymore. Thank you guys for joining and following this this adventure. I don't think I will stream anymore on that because if I do random tests, it will probably require lengthy builds and stuff like that. So there's really no point in me streaming and talking for 30 minutes while we wait for a build just to see a 5-minute result. But I will clean up what I have sufficiently so that I can push it so that people can reproduce. And by people, I pretty much only mean Peter, because I don't know how many of you have a quad HyperRAM PMOD. But I will definitely keep posted on the 1BitSquare Discord and on Twitter probably. And what I will probably do is once it's cleaned up and once I possibly have done a couple of like showy thing or anything, is just make like a 10-minute video summarizing kind of how this works, and show off a couple of things running on it. And I say 10-minute video, but I'm sure it's gonna end up being 40, but yeah, whatever. Anyway, thank you everyone, and catch you next time. Bye.